group, we got something called the PI code, which is a program identification code. Every radio station has their own code, okay? It's 16 bits code. And on the second block, we got a group code, and which basically advertise what kind of data we're going to send to you, okay? So this is a TMC messages, or this is going to be clock information, or this is going to be news information. So we're going to classify how these 5 bits are going to be used and how the subsequent group blocks are going to be used. This has to do with the version that we're going to use. TP is traffic program. It's 0 if there's no traffic problem going on at the moment. If 1, if there's a traffic problem going on. The PTY code tells you what kind of music you're listening to. So there's a bunch of code saying this is jazz music, country music, blues music, whatever. And then we got a check word, okay? And then block 3 and 4 are used depending on what kind of packets we're going to transmit, okay? And this is TMC. So TMC, we got the PI code in block 1, and then the check word. We got our group code, which in our case, it will be either 8A or 3A. So I'm going to show you that. We still have TP, PTY, and stuff. And then the 5 bits are going to be used with this kind of bits, T, F, and DP. We're going to see what's their meaning. And then we got, you know, something called direction, the extent, the event, and then the location code, okay? So this is how it's going to be used. So T, F, and D are used for multi-group messages. So in TMC, we can send a message within 4 blocks, or we can send a message within multiple groups, okay? So with those bits, we're going to advertise that, okay? DP stands for duration and persistence. So I get an incident or a queue. We're going to know how long that queue is going to last. If it's just a 50 minutes event, if it's just a whole day event. So if we get a message which is about, you know, emergency telephone not working, that's probably going to be a all day event. If we get an incident, that could be last 1 hour or 2. So that's what's being used for, okay? Diversion advice. So diversion advice, the satellite navigation system tells you that you really want to take a different route because there's an accident, okay? So if the diversion advice is 1, you're going to get a pop-up from your satellite navigation system telling you, look, okay, there's an accident, so I suggest you that you take a different route, okay? And then you can either plot a new course, and the satellite navigation system is going to automatically plot a route, losing, you know, the incident or the event, or you can just return and go on, and then you're going to encounter the event, okay? So that's very important. We're going to see how it's going to be used, okay? So events that don't have a diversion, like emergency telephones not working, or snow, or bad weather, usually you don't get a diversion advice for that, okay? Then we got the direction. So remember, we want to be space efficient, okay? So in the location, we said, okay, we're going to have this event on this highway, okay? With the direction, we're going to say on which direction actually the event is, okay? It could affect both, or it could affect only one of the two. Then we got the event extension. So if we get an accident or a queue, we want to be able to know how far the queue is going. If we got a 3 kilometers queue, or if we have a very localized queue, okay? Then we have the event code. So the event code actually, it's the piece of information that tells us what kind of event we're, you know, going to look for. So it's a code, and your satellite navigation system has a table with all the codes, and then, you know, a proper long description that, you know, translate that code to actually a real usable information. So, and the event codes used for TMC are a subset of what is called the traffic management data dictionary, okay? And the location code tells you where the hell the event is, okay? So since we want to be space efficient, we're not sending actual GPS coordinates of the event. We're just sending a code which our satellite navigation knows about, and then it can map your code to GPS coordinates, okay? So what happens here is that every country has a different location table, okay? So that number is 16 bits, so we cannot have many locations. So this is very important. We cannot have a traffic information event everywhere, like at your house or amusement park, whatever. We can only have a traffic message event in locations that are present in your location table, okay? Otherwise, that's how it works, okay? And this location table, sometimes it's public, so you can go to our website and download it for your country. For instance, I think Germany and Italy's location table are free. Or if you want, you can just, most of the times you can get the DVD, the Maps DVD, which is in your satellite navigation system, and you can, get it from there by doing some small hacking. So it's not legal, but you can do that. So we wrote a tool which is called SRDSD, which is simple RDS decoder. It's open source. It's online. You can get it and play if you want. You can build this stuff and you can play with it. So it performs nearly full RDS TMC decoding and also basic RDS information. Okay, so you build a circuit. You point this tool to the raw data that you're getting, and you decode whatever is going on. Okay. And one thing that you can do, you can pass a location table if you have it to the tool, okay? So the format of the location table is a standard, well, pseudo-standard anyway. And so that you can actually decode and mimic what your satellite navigation is doing. And this was the key for actually seeing if our injections were successful or not, and for actually understanding what was going on, okay? So the first thing you need to do when looking through RDS stream is finding the pi code, because the pi code is going to be in the first block of every group. Okay, so that's going to be the most recurrent string in your data. And if you find that, then you can lock on that and then decode all the stream. Okay, so the pi code is usually public. There's lots of websites with Excel sheets and stuff, and you can if you want to listen to that specific station, you Google for the pi code and you can find it, okay? So then you can pass the pi code to the tool. Or if you want, you can just search for the most recurrent string. So in this case is 5218, and that's actually turned out to be the pi code, okay? So 5, the first digit is 5, Italy, all pi codes from Italy are 5. So probably the United States, they have their own pi code set, and so on. So once you get that, you can decode the stream, okay? And this file, the raw stream, is just a series of zeros and one, and it is the output that you get from that kind of circuit, okay? So this is a, standard RDS messages. It's a 0A group, so this is tuning information, okay? And tuning information is also the one that's being used for telling you the name of the station. So if you see here, we got program name, and we got 2 digits, okay? So in that case, it's RT, okay? And the tool is also going to cache all the information that was seen so far about tuning information. And this is the collected program station name, this is a famous Italian broadcasting station, is RTL 102.5. So you can get maximum 2 digits in a packet. Okay, this is very useful for debugging, because if you're listening tuning on a radio station and you know the name, then you can, with the tool, you can see if actually these packets make sense, if you're actually seeing the proper name of the station. If you're not, it means that something is wrong with the circuit. If you get, garbled transmission, it means that either there's static, so you're not getting proper data, or something's going on, okay? And the problem about this, since we're talking about zeros and one, and it's a very small, data set, it's very easy to get, incorrect bits, and then you get something that makes sense, right? So you get some kind of event in some location code, and you're not able to figure out if it's wrong or not. You can compare the checker, of course, but, that's not 100% assurance. So one of the easiest way for, seeing that you're actually doing you're taking a good dump of the traffic is actually checking the program name, okay? And it's a very warm feeling when you code all of this, and you heat it up to the circuit, and you see the radio station, you're like, oh, it's cool. So it's like reinventing FM radio, but still, I was happy. So this is a TMC message, okay? So it's a single group message, so we can see it over there, okay? We have no diversion advice, 0. So we have direction, it's 1, so it's minus. So depending on your location table, it's one of the 2 directions. This is the event, which is low traffic, okay, with average speeds of something. So in case this was a multi-group message, so what happens in multi-group messages, you can send more information. So you can send this low traffic average speed of 50 miles per hour or whatever, okay? So this is a single group, actually. And then we got the location code, which has been decoded because we pass a location table. So this is a big road in Rome, which is often jammed. So, you know, we're Italian, so we drive like Italians. So this happens all the time. So our country was very good for actually testing these kind of things because we get traffic messages all the time. It's just, you know, flooded by queues, traffic. So, you know, that's why we did it. And then we map that to a GPS information because we have the location table, and the location table maps codes to GPS information. So we get that. And we also provide a Google Map link so you can actually see if that makes sense. And then here you get the road data. Okay? And this is a free A group. So 8 A groups delivers the event, and 3 A groups deliver the TMC system information. They're used to advertising that radio channel is actually sending you TMC message information, okay? And this is very important because what happens, your radio doesn't know automatically where it's going, sorry, your satellite navigation system doesn't know automatically where it's going to pick up TMC information. So you need some sort of ping, of packet that advertises you, you know, here, I have TMC information. And this is done with free A groups. So what we're having here, we specify the location table number. So look, on this channel, we're using that location table number. And we have international scope, so we can send, you know, messages about different countries, which is a fairly common thing in Italy because, you know, in the north of Italy, we live in Europe, right? So we are surrounded by so many countries that this is very common, especially when you're near borders. And then we have national scope, regional scope, European scope, whatever. And then you got the application ID. So this number is allocated, reserved for TMC. So this free A group is not restricted to TMC information. It's used by many applications. It's called an open format standard. And you can tell what kind of information it's delivering by checking the application ID code. Okay, so that's how they're going to use the space. And of course, we add the row data in both binary and hexadecimal so that you can play with it. Okay, so we also have a version that plots everything on Google Maps. Okay, using their API. So this is important. You get a dump, you know, 1 hour of traffic messages. You plot it on you know, on whatever, and you see if it makes sense. Okay. So here we got lots of events near Rome, which makes perfect sense. So, and in Milan too. So if you actually zoom in here, I mean, it makes sense. So, some video clip. Is it working?
Yeah. Yeah.
Okay. So video play time. So we thought that since this is the hangover session, right? Because you're probably, you know, sleeping a lot. So we got a cheesy video clip, a cheesy short movie for proving how effective our research is and the fact that we're not lame. Okay? So do you want to see the cheesy movie? Oh, that's it. Okay. Good. Let's see if this works.
Okay, darling. Let's go home.
Okay, sweetheart.
I love my new toy.
I know. You love it more than me.
We have to the door.
There's no one on the street.
No. I trust in my nuts.
But I can see the house.
No.
Oh, fuck you.
Shut up.